right? Okay, and we need to understand also that this Nernst equation involves concentrations, okay, together with the potential of each metals or elements considered in your half cell reaction. If doesn't if it doesn't involve concentration, then do not use this equation, right? So sometimes there are also stoichiometric relationship on how to solve electrochemistry problems. Okay, but in here it's very clear. There's an potential or voltage. Okay, and there is a reduction potential for the two. Then we have the cell notation, and we have the concentration. The importance really is the concentration. If there's no concentration, then you cannot solve this Nernst equation. There's a limitation for this. Okay, like that. So you can really troubleshoot if this will be applicable or not. Okay, now going to the derivation of the Nernst equation. So, in electrochemistry, guys, we considered also the Gibbs free energy, just like in thermodynamics. Okay, so as we can remember, the delta G is equal to the delta H enthalpy minus the temperature times the delta S entropy, right? So, like that, delta G is simply our internal energy. So it is also represented as U. Really, delta U and delta G is that is similar. That's energy. Okay. So basically, our Gibbs free energy is the internal energy, something like that. Okay. U. Okay. The unit is joules, something like that. Okay, our entropy, the unit is joules per Kelvin, something like that. Okay, so we should remember a little bit review for the first law of thermodynamics. We don't review the zeroth law of thermodynamics or the zero law because it is only a thermal equilibrium, okay, of the temperature of the conductive materials. 1, 2, 3, if you put that in a solution, okay, a solution. Okay, now the first law and the second law is the more important. Okay, so it's in here. The first law of thermodynamics, sa ganito siya. Okay, the total heat energy Q is equals to the total energy or internal energy, okay, plus the total work. Okay, this one. Total heat energy is equals to the internal energy U plus work, and we know that work is equals to the pressure to the change in volume, like that. Okay, and then if we try to undergo gradient or differences in this equation for this each component, then we will have delta something. Okay, like that. So this will become delta U, and this will become pressure times delta V. Okay, if you try to break that one here, so that involves changes at point 2, point 1, initial and final sense. If we don't consider the final point 1 and point 2, then this as is, okay, like that. Get the point? And then for the second law of thermodynamics is equals to the Gibbs free energy, like that, and then delta H minus T entropy. Okay, like that. Like this. Delta G, delta H minus T, delta S. So this is the second law of thermodynamics. So what formula is this? Okay, this is coming from the Q. Okay, so Q is equals to, okay, so entropy is equals to, so T times S. Okay, so this is Q over T. So this is our entropy. The total heat energy content divided by T is equals to our entropy delta S in here. That's why we obtain this one. This delta S times T is equals to Q. Actually, this is also Q here. Sometimes confusing, right? Okay, but because the enthalpy also is a heat energy, and then Q also is here. So meaning to say, the total heat content is the enthalpy, right? and the Q is only the heat is being absorbed or the heat is being released. Get the point? Because these are all heat here, right? Okay, so take note. So delta G is equals to delta H, which is the heat content, total heat content is the enthalpy, minus the heat being released and the heat being absorbed. Because this is the formula of Q over T is equals to delta S. So algebra, delta S times T here. So this is really the Q. Okay, this is not the total heat energy. This is the heat energy being released and heat energy being absorbed, something like that. Okay. So sometimes, a little bit confusing, okay? But you have to interpret by your own way. Something like that. Okay? Now, there is also a formula that states delta G is equals to delta U minus delta S. Okay, in here, sometimes delta G is equals to delta U minus delta S. It's okay also. Substitute delta U here. So meaning to say, if that happens, meaning to say, you don't have delta H. Okay, meaning that the heat is zero in adiabatic, thermodynamic process. Okay, adiabatic, meaning heat is zero or there's no heat flow in the system, right? Because you eliminate the delta H, common sense. Okay, okay, now, okay, now we have also the Vantoff's equation. I'm just showing to you that delta G is coming from the thermodynamics, something like that. So Vantoff equation. So our Vantoff's equation, wow. So our Vantoff's equation is equals to delta G is equals to delta G standard, okay, plus R, E, L, and Q. Ganon. So this is being discussed in physical chemistry also and in thermodynamics a bit. But this is more discussed in physical chemistry. But the thermodynamics is only tackling this a little bit in connection with here. Okay, like that. And this is the parent equation where the Nernst equation coming from. Okay, now in electrochemistry, guys, so as discovered by Michael Faraday, right? Electromagnetism and electrochemistry, right? Now, Faraday constant is very important. Okay, so like that. So that's why in our Nernst equation there's always F. Okay, now in our electrochemistry we come up with a delta G, which is standard for electrochemistry that involves electrochemical cell. Okay, and this is not really derived, it's already a standard formula given by Faraday, something like that, okay, in electrochemistry. So we have delta G is equals to the negative N F. Delta G is equals to negative N F E. It's a long story, okay, because you need to, break down the oxidation and reduction, and then with the application of the Faraday. This is Faraday really, guys, F. And this E is the electrochemical cell that we are discussing in electrochemistry, that have a reaction cell, like the anode cell, or the oxidation cell, the cathode cell, and the reduction cell. So this is what we mean by E. But this E is really the potential or the voltage. Okay, not standard at any temperature. Okay, like that. Then if you consider also the standard, it will become delta G standard. Okay, I will put your arrow so that we can consume the space. So delta G standard, okay, is equals to negative N F E standard. As you notice, guys, we have also the delta G standard. All you have to do is to use the standards also, which is this delta G standard equals to negative N F E. Why we don't put standard in N, number of electrons, and the Faraday constant? Because it is constant somewhere along the way. It is not variable. Okay, the only variable is most of the times the potential or the electrochemical cell potential, which is the E standard and the E cell here. That's why we don't put the circle. Okay, since our parent equation delta G is equals to delta G standard plus RTLQ, we have here the value and we have also here the value. Substitute that in the parent equation. Ganun siya. Okay, so substitute. Wait for a while. Charot. Okay. like that. Substitute, guys. So we have now, so negative NFE is equals to uh, negative NFE standard, okay, plus RTLNQ. So if we substitute that here, we come up with this negative NFE equals to NFE standard plus RTLNQ. So in here, guys, so there's common, right? Either we need to cancel this automatically because this is right and left, or we can divide this both by negative NF, common siya. Negative NF is common with the reactant and the product, okay, left and the side. Or we can cancel us out, but we need to both divide first by negative NF to simplify things, okay, something like that. Okay, so negative NF here. Okay, what will happen? It will become cancel. Okay, sorry, NFE, big E, not small letter E, sorry, big E. Okay, so cancel the N, the NF, sorry, the NF. So what will remain now is the E cell, because E standard, then negative, okay, because it's negative NF, guys, this portion here will become negative, automatic negative RT LNQ over NF. Okay, so RT LNQ over negative NF. Okay, now guys, in this equation, as you can notice, these are all the the numerator and the denominator. Then since we know that the R, the T, and the N and the F are grouped together, and the reaction quotient will be isolated away from the other side because it is not the constant involved. It's in here where the constant involved. Okay, so we need to isolate. It will become now E, which is E cell we refer to. A substandard cell is equals to RT NF LNQ, like this. Q is equals to the product over reactant, like that, or the anode over the cathode, something like that. Reaction quotient, Q is the reaction quotient. The reaction quotient is simply the constant, okay, like this. It will not become QP over anode over cathode. This Q is the reaction quotient, like that. So this will be now your equation here. Okay? Like that. So minus talaga siya yung original. And then other reference, we try this to be positive. That's why our reaction quotient will be R over P and cathode over anode. But we don't complicate that one, right? We use really the negative because based on our derivation. Okay? But others only others discussion is positive, or reference materials like that. I saw a research. Okay, like that. It's gonna be like that. And then the other one will be the logarithm. This is the natural logarithm part, equation 1. Okay. How about the logarithm? The logarithm, as I told you, is equals to E cell, E standard cell minus 0.0591 over N, and then log Q. Now, why 0.0591? Where can we get that one? I will show you. Chart. Okay, so like that. So we have E cell is equals to A standard cell. Guys, if we don't put cell, that would understood to be cell or electrochemical cell, because we need to save time, understood, something like that. But to be precise, this must be a cell on the subscript because this is electrochemical cell, meaning the chemical reaction to produce electricity. Okay, that's why electrochemical cell. But others discussion or reference point don't put cell, but it would be understood. that E cell is the potential of the electrochemical cell. E, potential meaning voltage. You don't forget a voltage. V-O-L-T. Okay? Like, so ganitong voltage, sa may formula sa voltage, it could be joules per coulomb. Okay? In this part here, guys, here, in our equation 1, in this part, you can obtain joules per coulomb. And then you will wonder why. Wait, this is voltage, volt. Then you will say, I cannot subtract because it has no the same unit. But you can subtract because G over C is just a volt. Okay? So, G over C or joules per coulomb is just a volt. So, you can subtract directly. Because this can be found in the current is equals to the charge over the time. Something like that formula. Or in the formula, power is equals to charge over the voltage. It's gonna be the power Q times the voltage because power is energy also. Electrical energy we're referring here. Okay? It's gonna be the two only. The current in terms of the electrical charge and then current formula in terms of electrical charge and the power formula or electrical energy formula in terms of the charge also Q. Okay? Parang good guys siya, di ba? We memorized already that 1 volt is equals to 1 joules over coulomb, and 1 ampere is equals to 1 coulomb over second, like that, okay? We memorized that already, right? And 1 ampere per second is equals to 1 coulomb. Actually, you don't have to memorize that one, but if you have the formulas memorized, you can easily adjust for the units. But for me, I found it easier if I will memorize the units. For me only. Okay? Like that. Okay, now, so the logarithm thing, okay, is 0.0591 and logarithm of Q. The Q here is just the same guys because it's also Nernst equation. This one. Okay? Now, where did we get this one? So, if we have here, guys, actually, it's just the same. If you leave the R value 8.3145 times the temperature 298, okay, times the Faraday 9645, because the number of electrons is variable at the end. So, this quantity here will be equal to 0.0591, okay, if you take the logarithm of the ln here. Okay, there is a value here, right? And you need from ln to logarithm, and then you can obtain the logarithm, which is 0.0591 logarithm q. So how can we do that? So in I reviewed a little bit in the logarithm rule, something like that. Okay, just for explanation. Anyway, but this is very long time ago, 20 years ago in my college education, okay? But I have to review for the purpose of discussion also, and it helps me a lot also to understand a bit, okay? So we have, okay, ln x is equals to logarithm, ganun siya, 10x to the base, ano siya. Since this is from ln to logarithm, in which we can get this one, okay? Now remember this one can be obtained also this value by multiplying the the RT over NF katong may mga Faraday, something like that. But we need to find out why this 0.0591. Okay, so okay, now this ln x is equals to logarithm base 10. Logarithm have always a base 10, something like that. Now, so take the e for the 2, the ln e x, because that's the rule for natural logarithm always, all the time, most of the time. So ln e is equals to 1. So ln e is equals to 1. So automatically this is x already. Is equals to log 10 to the base x. Now you put also e on the other side because you e on the other side, right? Like this e, ganon. So it will become now also logarithm 10x e. Okay, now by the rule of the logarithm, guys, as I reviewed, it will become logarithm of 10 like that over logarithm of e. Okay, like that. Okay, something like that. So we have the value of logarithm 10. Let's check what is the value of logarithm 10. Okay. Since we have the x here, right? We still have the x. Later we will use the x. So for the purpose of proper solution, we don't need yet this x later. Something like that. So x, or actually we can present another that is y to not to confuse the x here. Okay, let's say y. This one, huh? Because the other x is for the ln man siya to avoid confusion. The declaration of the variable or letter should not be the same, right? Am I right? Because this will become y. See, so log 10y siya. Okay, since log 10y siya, and this is a letter, so we can say also y log 10, right? So y log 10. So y log 10, so y log 10. So logarithm of 10. This is e, ha? Y log 10 over log e is equals to x. The purpose of letting this y for the logarithm not to be the same with x in the ln, but it's just the same, but so that we will not be confused only. Okay, like that. So the log 10 calculator, how much is the log 10? Okay, the log 10, guys, is log 10 is equals to 1. So this is 1 over, like this, the numerator. So log 10 is 1 times y. Okay, log e, how much is the log e? Use your calculator again. Log e. So log, okay, this is 0.4343. 0.43 is the log e. Okay, 0.43, like that. Ganon siya. So x is equal to this one. So y times 1 is y only, and then 1 divided by 0.4343. Okay, pila siya? Okay, 1 divided by 0.4343 is equals to 2.303 na siya. So 2.303y. Ano na siya? When x is equals to 0.203y. Okay, now, since this x is representing the natural logarithm, and this y is representing the logarithm, right? Because that's why we need to avoid confusion. So it will now become ln, which is the x we let, and 2.3303 is equal now to the logarithm, this one. So we have now ln is equals to 2.303 logarithm. Okay, now we will substitute that in our equation here, this one. Okay, so that we can obtain this one. Okay, like that, or substitute this one here automatically. Oh no, we should go back to the parent, this one, because it is already the final, right? Why it come up like this? So we need to go back from here. Itong may mga RT. This one, sige, substitute na. Okay, we should substitute this. Sorry, we should substitute this the value of ln, which is 2.303 log, right? And then we substitute that here because we have ln here, right? So the value of ln here is 2.303 log. We will substitute that one here. Okay, now, okay. Just now I tried because, I only researched the logarithm and review the logarithm rule, but I never do the actual substituting just now. Okay? Let's try because, let's do it because, I don't want to be magic, which just 0.05 and 1 come out. Okay? So I need to prove something like this. Okay? So it's gonna be, okay. So E cell is equals to E, cell substandard is equals to 0.0591 divided by logarithm of Q. Now we have the other one, which is E cell, okay, is equals to R T N F ln of Q. Now we have here ln is equals to 0.303, okay, logarithm. Okay, now substitute this ln equals to 0.03 logarithm. Sorry, logarithm pa siya, ganon. Substitute that here ln, and substitute the r, the values of r, t, and let's see, it will be equal to this. Okay, let's try for the first time because I'll never solve this in actual. I only researched the rule of the ln to logarithm, but I'll never try. If you substitute this one, it will become like this. Okay, let's just prove this. Okay, and then we repeat again if this will not be equal, something like that. Most of the times the vloggings are like that, right? I have to repeat again if this is not correct. I have another trial, and then after that I can get the correct answer, something like that. Because if too much scripted, then it will be perfect. Okay, like that. So E cell, mag-substitute sa taha. Okay, E cell is equal to E substandard cell minus universal gas constant 8.3145. Kaning universal gas constant, guys, memorize this because this will be always used, especially in the Boltzmann constant that we obtain 1.38 times 10 to the negative, negative 23, right? You remember that one? So, because that is Planck's constant, this is a Boltzmann constant is equals to the universal gas constant divided by the Avogadro number. Okay, Avogadro number 6.023 times 10 to the 23. Okay, ganon. Muna nakakuha tag Boltzmann constant. Okay, so ganon siya. And then kung makakuha po tag Faraday na value 96485, the Avogadro number also is very important. Okay, like this. Let's say memorize the constant. Not all, but the most commonly used, or let's say to prepare yourself, right? Much better to memorize many constants rather than only few. Correct me if I'm wrong. Okay, so 8.3145. So joules per mole Kelvin times 298. Why 298, guys? Because why 298, guys? Temperature and R is like this. Why 298? Because at 25 degrees Celsius man siya, standard. Okay? And then the number of electrons, in which we're not yet concerned for that. And our Faraday is 96485. And then Coulomb, mole, electrons. Like that. Okay? The moles will be cancelled, the Kelvin will be cancelled, and the electrons also will be cancelled here because the N here is also the electrons. So the electrons will be cancelled here, somewhere like that. Okay, so our unit here is GC, as I told you, right? G over C in this thing, G over C, in which the A cell is the voltage. So you can subtract directly because GC is just equals to volt or voltage. Okay, so now the ln. We have the ln, right? So the ln, we have 2.303 lag. Substitute that here. So let's put bracket to simplify. So 2.303 lag Q. So ano na siya? So 2.303 lag Q. Let's say if this will be like this, ha? Try lang. Okay? Okay. So, ganon. So, 8.3145 times 298 divided by the Faraday constant, 96485 is equals to, this is 0.0256. Let's put that here. So, E cell, negative 0.02568 02568 over n times 2.303. Then the logarithm of q. Okay. Now, perform the operation. This will become 0.0591. Okay, let's check. Okay. 0.02568 times 2.303. Yes, equal to 0.0591. See? Okay. That's why we have this formula. Because it's coming from here. So this is the more simplified compared to the RT over NF, right? If you don't want to use the ln, if you're not comfortable to use the ln, then use the log. But this one is the most simplified because substituting values already in here. That's why I use this, right, in my solution a while ago. I never use this one because it is very tasky. Okay. Anyway, the ln and logarithm can be done in the scientific calculator. There's no problem about that. But you know how tasky to put this one like this. So it will take a lot of time. So I will rather use this one in Nernst equation. E cell is equals to E cell substandard minus 0.00591 over n logarithm of q. But if you want this one, if you're comfortable, then you can solve also, no problem. The advantage of this, guys, is if you know the constants very well, then you can solve perfectly here. But if you forgot this 0.0591, something also wrong. Okay, so that's why you memorize this 0.0591 all the time in your brain cells. This one is already familiarized man siya, yung mga R, mga TR. More na yung advantage niya. Okay? But there's a lot of also of memorization here. You should memorize the Faraday constant. Gas constant it's okay because it's always used all the time in the ideal gas law. Okay, most of the times, right? But this F is not really memorized all the time by engineering students. Really sure. It's not memorized all the time by engineering students. Okay? Because this is specific or specialized to electrochemistry. Okay, 96,485 coulomb per mole electron coming from the electric charge 1.602 times 10 to the negative 19 coulomb by discovery of Mr. Coulomb. So, meaning to say, Mr. Coulomb and Mr. Michael Faraday discovery is related to each other. Okay? We don't have a Faraday theory or constant if Mr. Coulomb discovery was not existing, something like that, or was not existed. So, related siya. Okay? Now, again, this all derivation of Nernst equation is coming from the Vantoff's equation. As I told you a while ago, gives free energy delta G is equal to the standard gives free energy plus universal gas constant capital R times the capital T times ln natural logarithm, okay, times Q. Q is the reaction quotient. Okay, reaction quotient. It's not the heat energy, ha? Don't be confused because capital Q also in the oh my goodness, capital Q in thermodynamics is the heat energy, right? But in here, reaction quotient, the same as the equilibrium constant in chemistry, the concentration of the products over the concentration of the reactant, equilibrium constant, okay? But in here, since this is electrochemistry, we are using the cathode and the anode. So our product will be the anode and our reactant will be the cathode, something like that. Then if we try to avoid negative, positive here, you can also use, but be careful with the reaction quotient. It should be reactant over the product or the cathode over the anode. It's in here also. Okay, because other discussion also, some professors and doctors in which I really saw, okay, I researched for that, is they are using positive. Okay, and you may wonder why positive like that, and you must also have your own research why. Okay, you know, I don't see that like that. It's only my interpretation because I tried. Okay, when I reverse that one, it will become positive by my own initiative. Okay, my gosh. Okay, I researched this, but I wonder why there's a positive equations for this. Then I'll try to come up. I want to dig it out. Okay, what's happening for this? Is that the same? So what I did, I'll try to have a lot of trial and errors by myself only before this vlogging. Okay, like this. So this is gonna be like that. Okay? Just like the Arrhenius. So, ganun siya talaga guys. Pag the books are not negative and then the discussion of your instructor is positive, there's something wrong there's not wrong, there's something it's gonna be reversed. Okay? Because if you try to reverse that one, the sign will, ano man siya, will matter. Will change also. Okay? Just like that. Okay? Oh my God, sakit kaya ang ipon. Okay, thank you kayo for watching this short live stream. Oh, short live stream is just 35 minutes. Okay, you can comment down below in the comment section. Subscribe my YouTube channel if you want to, and you can click for the notification bell for some of you stuff is everything. Our channel is bye bye. God bless everybody. It's already midnight here. I still don't sleep because I don't feel asleep. Gosh. Thank you. Bye bye. God bless everybody.